Hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm going to be working on the TRS-80 Model II again, specifically the 8-inch disk drive that was in that machine. I want to test it out, and I want to see if I can make a floppy disk, so when I get that machine working, I can actually boot into the OS and see if I can use that computer. So without further ado, let's get right to it. So this is the actual drive that came out of the TRS-80 Model II. As I had mentioned in previous videos, it's a Shugard model number 800-2. As far as I'm aware, in non-IBM equipment, this is a relatively common model. I still have this lower mounting bracket attached to the drive because it doesn't interfere with any servicing of the disk drive. And of course, this is what angles the disk drive to the correct angle for the case opening on the front. I think before trying to get this drive working, let's dig into the actual history of the floppy drive and specifically the 8-inch floppy drive first, so we can better understand what I'm going to be trying to do here in this video. Let's first start over here on Wikipedia, and it's the article on the floppy drive itself, or rather the floppy disk. The article states that after development of disks in the late 60s, it was 1971 where the first commercial floppy disk was released, and then soon after other companies joined on the bandwagon. The disks and associated drives were produced and improved upon by IBM, but also other companies like Memorex and specifically Shugard Associates, which is this drive we have right here. This is made by Shugard Associates. But it definitely seems that IBM's 8-inch disk, or the Type 1 diskette, was sort of the industry standard in the 70s. It was in 1976 that Shugard Associates introduced the very first 5¼ inch floppy disk drive, the SA400. And here's a picture of it. I think anyone who's ever used an old retro computer from the 70s or into the 80s is very familiar with this drive. Now the funny thing is, many companies made clones of this disk drives, and with slight improvements. And while those clones look the same on the front, internally they were a little bit different than the Shugard first disk drive. This is the service manual for the SA400, and it's an incredibly detailed document that explains exactly how the disk drive works to a very comprehensive level, and allows you to fully service any of these original SA400 drives that you may come across. It was Steve Wozniak who ended up buying the SA400 mechanism from Shugard minus the electronics board and coming up with a new analog controller that went with it that would actually make it work with the Apple II and be so much less expensive than the original SA400 mechanisms that were used on other competing computers. Shugard called the mechanism on these drives, if I recall, the SA390. And there's a little bit of lore that Shugard actually sold sort of bad mechanisms to Steve Wozniak for development, and he was able to still make those work with his clever engineering of the electronics. Anyways, like I had mentioned, by 78, it says here, there were, I guess, 10 manufacturers making disk drives that were sort of clones of the original Shugard 5¼ inch. And it didn't take very long for the 5¼ inch format to displace the then common in the 70s 8-inch format that IBM was basically pushing with all of their machines, and other machines like the IMSA 8088 and Altair typically would have 8-inch disk drives as well. I won't get into too much more history, but obviously 5¼ inch disk drive lasted for quite a while, but eventually was replaced with things like the 3.5-inch floppy drive that was made by Sony, and there were some other competing formats that had less traction and eventually went away. Now going back to the difference between 8-inch and 5¼ inch disks, the obvious being the size is different. The disks are otherwise relatively similar. They're constructed in a very similar fashion, where there's a felt material on the inside and a magnetic disc that spins, and there's a floppy, flexible case on the outside. The big allure of 8-inch disks was that they could hold quite a bit more than the contemporary 5¼ inch disks. And that's kind of the reason why I'm assuming that Radio Shack, Tandy Radio Shack ended up using this larger mechanism for the Model II versus 5¼ inch discs, because at the time of the release of the Model II, absolutely 5¼ inch drives were available, but I guess that these larger drives were just considered the more professional option, as that is what IBM was pushing with all of their professional level machines, but also the capacity was greater on these. In the late 70s, when the Model II was released, it was pretty typical that 5¼ inch and 8-inch disk drives were single-sided, meaning there was only one read head, and it's on the bottom side of the disk. What you see right here on the top is simply a pad that pushes down on the magnetic surface so that it contacts the read head properly. These 8-inch drives spun the disk faster at 360 RPM and also had 80 tracks versus the more common 35 or maybe 40 tracks on 5¼ inch discs, giving you a substantial increase in capacity. There are probably people that have a bit more familiarity than I do, but I think at the time as well, it was considered that these drives were a bit more reliable, and the discs that went with them, than the 5¼ inch floppies as well. Back on Wikipedia here, there's a little table showing the capacity of these different disk drives, and all of these are going to be 8-inch drives right here. So 1973, the Shugard 901 could hold what it looks like about 242 kilobytes. And that was a single-sided, single-density disk, meaning that it was using FM encoding versus MFM encoding on an 80-track disk. When Shugard released the SA400, it would have been using a single-sided, single-density or FM encoding for a marketed capacity of 110 kilobyte or a formatted capacity of 87K. The Apple II, using the exact same mechanism and some neat, tricky encoding, actually increased that up to, well, I thought 140K, but maybe the formatted capacity is actually 113 kilobytes. This table here is specifically missing the SA800-2 that we're going to be working on today, but from my understanding, it of course fully supports MFM encoding, so double density, but unlike this one here, which says double-sided double density, it's going to be single-sided and double density. I just realized I've been talking about this disk drive without showing a comparison to how big it is and heavy it is compared to the 5¼ inch disk drive. This is a 5¼ inch disk drive, and if I hold it up to the 8-inch drive, you can see right there how much smaller it is. Now this is a half-size one, but of course a full-height drive would be the same size this way. It's just going to be twice as tall. But you can see, compared to the 8-inch drive, the massive shrinkage that has occurred from this one to this. And you can be assured that from a weight perspective, this thing is built, it's so solidly, it's just hard to describe how ridiculously overbuilt and heavy this thing is. Now let me turn the 8-inch disk drive around so we can look at the drive electronics. One of the things I want to do with this disk drive is I want to test this out on a PC. And that's, of course, for two reasons. The Model II is not yet working. I haven't managed to get that computer to power on yet. Well, I haven't even attempted it. And number two, I have some good tools on the PC for testing out disk drives. Now, you're going to say, well, there was never an IBM PC that used an 8-inch disk drive, and you'd be absolutely correct. And if we look at the interface connector here for the Shugard drive, it's this edge connector that's relatively big. And if I hold the 5¼ inch drive up to it, you'll notice there's a difference in the number of contacts on this edge connector, meaning that it seems like there's not going to be a way to hook this drive up to a PC because it doesn't have the normal 34-pin cable like a 5¼ inch or a 3.5 inch drive does. And yes, this is indeed actually a 50-pin connector. But the thing is, Shugard, when they designed this disk drive, well, they didn't design this exact one because this is not one of theirs, but when they designed their 5¼ inch disk drive that everyone copied the interface protocol for that drive for all of these other disk drives, and that includes 3.5 inch drives. They use a pin connector here, but it's still using the same Shugard SA400 type signaling that that very first 5¼ inch disk drive used. Well, it turns out that when Shugard made this SA800, which I'm not sure if this came after the 400 or before it, I think it came after it or around the same time, that they used exactly the same signaling on this disk drive as the regular SA400 uses. What that means is that if we can adapt this connector to a PC cable and a PC interface card, we should be able to control this disk drive without any problem. There's also going to be a couple other things that are going to make it harder to use the 8-inch drive on a PC versus the 5¼ inch, and it comes down to power. One major thing about the 8-inch drive that is so different than every other floppy drive or any computer peripheral you've ever used is that the motor that turns the disk, that turns the spindle, which on the 5¼ inch disk drive is this thing on this direct drive model, and on older full height models, there's a little motor in the corner with a drive belt. That is this thing right here. This is the motor that turns the spindle. But if I flip the drive over, take a look at the specs on this. 7.5 watts, 115 volts. And it's also 1500/1800 RPM. The difference there is that this is what I think an induction motor. I'm always messing up the terminology, but that is 1500 RPM at 50 Hertz or 1800 RPM at 60 Hertz. Yes, this drive motor, it's powered by line voltage. And that means when you turn on the machine that's using this disk drive, like say the Model II, this drive just runs all the time. Now if I flip the drive around onto its bottom here, this is the spindle that actually turns the disk, and there is a drive belt, it's right here, that goes around under the PCB here to that large AC motor, and this whole thing is turning all the time. Well, if you've ever worked on AC motors, like on your air handler in your furnace, for instance, motors like this require a run capacitor, and that is right here. And it looks very much like a run capacitor on your air conditioner. In fact, it might be a start and a run capacitor. I think there's two capacitors in here together, and this is absolutely required for this motor to work properly. So to do any kind of testing with this disk drive on a PC, I need to power up this motor with mains AC voltage to get the disk spinning. And this is the connector that makes that happen right here. Now on the Model II, there's a distribution block in the bottom of the computer that takes the mains power and rounds it to the power supply for the machine, and then it also runs it to this. So when you turn the main power switch on, it powers up the disk drive. In fact, this is the harness that came out of the Model II. Now this is the connector that goes to the disk drive here. I think this goes to the power supply or something. Anyways, all of these terminals here were on a screw terminal block that did the power distribution, and there were some other cables that went to the IEC mains input. There was an inline fuse, and of course the power switch. To avoid cutting into this cable, I luckily have another connector that fits into here, and this actually came off another 8-inch disk drive that I have, and I have adapted it with this little coupler here onto a mains AC cord. Now the problem is, of course, is that this is not fused. I don't know if this thing works. The original Model II would have had an inline fuse on the mains AC. It's probably dangerous to run this thing without a fuse in case there's something wrong with this motor. Could melt this wire, cause a fire, who knows what. So I'm going to run the disk drive on this, which is an isolation transformer that is rated about 45 watts. It has fuse holders right here. So this is fused internally, and it has a mains cord here for the US plug, and I can plug the disk drive into this, and that offers two benefits. Of course, it will isolate this AC motor here, so if I touch something exposed, I will not get a shock, hopefully. And then in case this thing is shorted or something bad happens, the fuse inside the isolation transformer will blow. The next problem is this right here. And this is the DC input for the disk drive, and that's going to run the drive electronics, but also this rather large motor here. This motor here is the stepper assembly for moving the head around. And as you notice here, it's a relatively big and beefy motor. It's not like this little piddly stepper motor on the 5¼ inch disk drive. You need something a little bit more substantial to move the head assembly around on this rather large disk drive. So to that end, this thing runs off 24 volts. Not something you typically find in a regular PC on the power supply. In addition, because this is a product of the 70s, some of these ICs here require -5 volts, at least on this version of the drive. I think later versions of the SA800 only needed +5 volts. They still needed 24 volts, but the -5 was not required anymore. But this one, it does need it. The connector down here is also non-standard. It's nothing like the Molex connector we have on PC disk drives. And this is the power supply harness from the Model 2. So this large connector goes onto the power supply, and then these two, I guess one is for the disk drive and one is for the card assembly. Funny, they're both exactly the same. They seem to have different wiring in them though. But I don't want to cut this or modify this harness in any way for testing of these disk drives. Well, that's where this comes in. This is another SA800-2, exactly like the one from the Model 2. This did not come out of a Model 2 machine. This was given to me by a local viewer here in town. Actually, I got 2 of these, and they came out of some kind of large word processor or something like that. I think it was made by NEC. The rest of the computer, unfortunately, was sent off to scrap, but the disk drives were saved along with the wiring harness from them. So I have 2 of those connectors, and also this was the end that went to the power supply, and the wires, even though they're all white, are labeled. So with this harness, I just need to get this connected to the correct voltage rails, and I'll just need to use my bench power supply for the 24 volts, and I can use my PC power supply for the plus and -5, because I'll be using my old AT power supply, and it does have both of those rails available. So that solves the problem with the DC power and the AC power. But what that does not solve is still how to hook it up to this 50-pin edge connector. Well, luckily, that's not a problem either. This is the original cable that was in the TRS-80 Model II. This connector here went to the disk drive controller. This went to the floppy drive itself. There was only one internal drive. And this went to the back panel for hooking up to 3 external drives. I thought about using a SCSI cable to make an adapter that would go to this cable and then hook up to a 34-pin connector for a PC controller. But while I was searching on eBay, I found a seller selling a Shugard interface 50-pin to 34-pin adapter, which I purchased. It was relatively inexpensive and it came very quickly, all the way from France, I might add. Has the 50-pin pin header here, along with the 34-pin one to hook up to a PC cable. Has various jumpers to allow you to configure drive select and stuff like that. And I think with this, that almost completes the connectivity. But the one thing I can't do is easily connect this cable or this adapter to this edge connector. So I think what I'm gonna do is I'm gonna take this original cable and I'm gonna crimp on an extra 50-pin connector onto this. This here is a long SCSI cable that I've used for other purposes, and it has the appropriate 50-pin connector on here that I need. So first thing I need to do is get this connector off of this cable. And I've already done that. Where is it? Here we go. You notice there are holes here, and that's because I peeled a 50-pin connector off this already to use it for something else. I have an X-Acto blade in this, and I think it should start to come apart. And you can see there's a little bit of a gap forming right there. So I don't need to do it anymore. I'm just gonna do the other side, same thing. I know it's not gonna be easy to see, but you just kind of pry this open and then you start to pull this away. And every one of these is going to be manufactured slightly differently the way they're made, so your mileage may vary, but usually these are easy to take apart. And I like these connectors on this cable because they're actually metal, the little clips. A lot of times they're just plastic. Okay, I'm going to pull the cable out. You have to be very careful when you do this because if you're not careful, you can actually pull the metal pins right out of the connector. So you just have to kind of carefully pull this up. Now don't worry if they do pull out a little bit, because you can push them back in actually, at least on the good quality connectors like this. There we go. So the connector is in perfect shape. There is no issues. Same with this top piece here. Now on this adapter here, it has a little pin 1 indicator. Hopefully that's showing up on the camera. It's right there, there's a little arrow. And there's actually a notch in the shroud, I guess, whatever the part that goes around the pins. Now, of course, the notch normally goes into or lines up with what's on your connector, but if you notice, this one is notchless. But it does have these grooves here, and there is a pin 1 arrow as well. And the grooves always face towards the notch. So the notch is facing towards the camera, and the way this would go on would be like this. Now there's the pin 1 notch right there, and it matches up with the pin 1 notch right there. So I want to make sure that the cable, when I crimp this on, that I'm going to be crimping it with the stripe of the cable towards the notch. So we know the notch is right there. We know the stripe of the cable is right there. I think I'm just going to put this like in the middle here. Now obviously when I put the Model 2 back together, this connector here is not going to be used for anything. It's just going to sit in there. So I don't think it really matters where I put it on the cable. And I'm just going to take this top piece here. So it just needs to be crimped on there basically at this point. Now there's actually a correct crimp tool to do this work. Do I have it? Of course not. I don't have that. So I'm going to have to improvise. Okay, so this is my bench vise. And I actually have 2 slot covers taped in here. And I'm going to use this to crimp the cable. I'm just going to kind of twist the cable around here so I can get it into the vise. And I've tightened the vise just so it's loosely holding it right now into position. And I'm just looking straight down to make sure it's aligned correctly. And it is, because all the little metal pins need to be aligned with the cables here. And I'm just going to start tightening the vise. It's now holding onto the cable itself. And it should start crimping. There it is. I just heard the clicks of those 2 metal tabs. As they went into position, it went click, click. And now I'm not going to tighten it too much because I don't want to crush this connector here. It should be crimped. And there it is. I do have it on the back side, but that was on purpose. The original cable modified with a 50-pin connector. And I know people are going to be like, oh, I ruined the original cable. The cable's not ruined. This cable's still going to work perfectly for what it was designed for. And this is a really good quality 3M connector. I didn't just use some cheap junky one on here. And I just plugged it in, and pin 1 on the connector is lined up with pin 1 there. And it's also lined up with the stripe on the cable. So I think this should be good to go for testing now with a PC. Yes. All right, so first things first, I need to test to see if the motor spins. And I'm gonna use this disk drive that was from the word processor because this thing was not exposed to the rain. There's no corrosion, it's just dusty. Unlike the disk drive in the Model 2. So I'm gonna pull off this, whatever's left of the original power cord. And this is the cord that I made, and the isolation transformer is not connected to mains yet. It is just right here, the plug. So this connector here, which says P28 on it, is keyed. So it can only go on one way. So let's turn this around so we can see the motor turning. I'd always intended to install a toggle switch on this little isolation transformer so I could turn it off and on with a switch here versus needing to plug and unplug this from the wall. So in the meantime, I'm going to use this little power strip here, which is currently in the off position. So let's plug this in. And here we go. Look at that. Okay, so it's working. This drive is working. Now it's funny, I really need to buy a tachometer or a little device I can measure the speed of things with, because I have no way to know what speed this is running at least right now before I hook this up to a computer. Now turning this around, as I had mentioned, this AC motor here is a synchronous motor, so it actually is locked to the line frequency. Well, since I have this drive out and I know it's at least turning properly, I'm going to do the rest of the testing on this drive using this cable and adapter. All right, this explosion of cables is everything connected up. So this is the harness here going to the disk drive, and this connection right here is the 24 volts. Now it actually has a separate 24 volt return, which is the ground. It seems the power that goes to the stepper motor here has a separate ground. So it's okay that I'm running from a bench supply that is separate from the rest of the voltages which are coming from the power supply underneath here. And then right here I have the +5, -5 in the ground, and I have that soldered on first to a Molex splitter right here. So that's plugged into the power supply for the +5 volts and the ground. And then there's a blue wire that's right here, and that's actually going to this ISA test card here. And I have a pin soldered onto the -5 connector there. So that is getting the -5 right off the ISA bus. Now you might be thinking that taking power from the ISA bus is not going to have enough power for the disk drive, but if we check the service manual here, -5 volts is only going to typically take 0.05 amps. So it's really, really low current, and that's really for bias voltages on the ICs on the drive electronics. The +5 takes 800 milliamps, which I probably could have gotten off the ISA bus as well, but I'm taking it from a Molex connector. And the plus 24 volts takes 1.3 amps typical, which is what I am giving it from the bench supply. Now, luckily, the wires on the disk drive end are also labeled for what's what. So I did check that I was getting the appropriate voltages on the appropriate pins before I plugged it into the disk drive. So I did this testing off camera. Now, this whole setup seems a little precarious, and it is, but I think I'm ready for testing. Now, of course, because the AC motor that drives the spindle is separate from the rest of the drive electronics on this, they're not connected in any way, I don't need to power up the AC motor to test the voltages going to the drive here. I think what I want to do first is power up the DC on this drive without first connecting the cable to the PC. I'm expecting the head might move a little bit when I first turn it on, but at the same time, nothing might happen. So down here is the power switch for the power supply, and I'm gonna reach up to the bench supply and I'm gonna turn them on at the same time. I don't know if it matters that they're on or not simultaneously, but I'm gonna do it as close as I can. It's drawing about 1 milliamp on the 24 volt line, which I can see on the bench supply, but otherwise this thing didn't do anything. So at this point, I'm gonna try to hook up this little mess of cables here. So I have the PC floppy drive connected to the twist portion, and I'm gonna hook this up to the drive. Now there's a few things at play that may cause this not to work right off the bat. There's some jumpers on the drive, which I haven't even looked at, and this is the one from the word processor, not the TRS-80. Also, there's no termination on this drive. It doesn't look like there's even a facility for it. It probably was on the cable on the original word processor, which I don't have. There are markings on here for drive select 1, 2, 3, and 4. It's weird it doesn't start at 0. It's currently set for drive select 1, which would be drive select 0. So I'm going to move this to drive select 1, or 2, sorry, which would be the same as the way all PC drives are configured. And this little PCB has some jumpers to configure for drive select, and it currently is passing through what is the drive select 1 signal, which on here is labeled drive select 2, so that should select this drive. I'm just gonna ignore the lack of termination right now, and let me power this on and let's see what happens. Nothing, seemingly. I'm gonna go into the BIOS on the computer and I'm gonna set up the A drive as 720K. So that's single density, but also 80 tracks. Now I don't expect this drive to just work with DOS, and I think that's because of the RPMs are different and whatnot, but at least there should be some activity of the head when it tries to seek. I am just gonna set this here to floppy drive seek at boot to enabled. Well, it didn't give an error about the floppy drive, but it also didn't seem to do anything at all. I'm gonna close this mechanism down so it may think that there's a disk in here. And I'm gonna run IMD, which is the tool that I'm gonna use to try to control this drive. So let's hit T for test RPM. Oh, okay. So it engaged this solenoid right here, and it's drawing 1.2 amps on the power supply up there. So the fact that it engaged the solenoid when it tried to read the disk was a good sign. All right, so it's not possible that I do anything without an actual 8-inch disc. And I happen to have a few of them. And here's an IBM 8-inch disc. As you can see, it looks just like a 5 1/4 inch, but much bigger, not smaller. So I'm gonna turn on the AC power, which should start the spindle. There it is. Oh, it blew a bunch of dust out of it. And I'm gonna take the disc and I'm gonna slide this in. It does need to be spinning for it to center the disc properly. There it is. The disc is actually spinning now. And I'm gonna try to format this disc. I'm gonna need to set this up. So sides, one side, double step is off. I'm gonna set the interleave to 1 because I don't really know what else to set it to. And I'm gonna try to hit F to format the disc, sectors per track. I don't know, I'm just gonna pick 9 because I don't really know the right number for this. Start sector 1. We're gonna do 250 kilobits per second MFM. Sector size 512. I'm just pushing enter on the defaults, and here we go. It is actually moving the head. It is entirely possible this drive hasn't done anything in 30 years. I mean, who knows when the last time this drive was even used? Look at that. It actually finished. Let me pick the option clean head, and that's just gonna move this head back and forth on the disk a bunch of times. Here we go. Look at that. It's totally working. All right, so I think it's actually seeking a little too far because it seems to be hitting a stop over on this end. Now on IMD, if I hit A for alignment test, it's gonna try to read what it just wrote to this disk. Ideally, you should be using a disk you formatted in another drive, which you know worked. Okay, so it's not actually reading anything right now at all. So the question mark should be showing the number of sectors it's reading back, and it's actually not reading anything. Okay, so I wanted to figure out what the format of this drive actually should be. And it looks like 77 tracks, 24 sectors per track, soft sector, and a sector size of 128 bytes. Gives you a capacity of about 250K. It does say the Model 2 has a double density controller, so the disk format could use 256 byte sectors, and then you get 492K. So why don't we give this a try? 24 sectors per track, start sector 0. Let's use MFM, which is gonna give us 256 bytes per sector. And here we go. Now while this formats, there's a couple things that might be preventing this from working. First off, there's no termination on this cable and all this assembly here, so that could be causing an issue. Second, the discs might be bad. I have no idea if these discs works. I found them at an e-waste recycler. They were just lying around, not even in a box. So who knows? Heads could be dirty on here, possibly as well. The disk drive might not be working. There might be some other incompatibility that I'm not aware of. I'm not sure. So there's certainly a lot of variables. It's nice to know that this thing is actually seeking properly and that the PC actually sees the disk drive. So that's cool. But it is the read-write signals that may not be getting through properly or maybe having other issues. So with format complete, let's see if we can read anything here. It doesn't look like it. IMD is still giving us the big old question mark. Okay, so I'm gonna exit out of that, and I think what I'm gonna do is I'm gonna take this disk out. And taking a look at the head there, I do see a little bit of something on there. So I'm going to give it a little clean. 99% IPA, one of these little strip things here. I gotta say, that disk surface, it doesn't look very good. It's not very shiny. So part of the problem may be this disk. It's just bad. Let me grab a different one. I have some more. Unfortunately, they're from the same batch, so they might all be bad. Here's another one, and it looks not great as well. Don't see any mold on it or anything. It just doesn't have the right shiny look that I'm expecting. Okay, and F to format. Nope. Well, since I'm lucky enough to have multiple of these drives, I'm gonna take this disk out of here, just make sure it doesn't look damaged. No, it looks okay. Let me grab the TRS-80 Model II drive, see if that works any differently than this one. All right, Model II drive. First we get a test to make sure that it actually spins up and doesn't cause a problem with the AC. So I'll plug that in first, just on its own like this. Let's see if it spins. Ooh, it does. Doesn't sound very good though. Those bearings, when I first took this thing out of the machine, the spindle wasn't turning very smoothly, and it certainly doesn't sound very good. Although to be honest, now that it's running, it actually sounds like it's maybe the grease inside there and the bearing is spreading out. Worst case, I can mix and match parts though, take the digital board off this and stick it on the other drive, et cetera, et cetera. It's definitely in a little bit better shape. All right, cut the power there. I'm gonna plug the DC into this drive. And then I move the jumper on the board there to drive select 1 so that the PC will be able to control it. Now, one thing I read, and if I look at the back of the board, I'm sorry I can't turn it around to show you, but a bunch of the little jumpers that were on the other one have these wire-wrapped jumpers, so to speak, that go from some of the pins to other ones. And I seem to recall that if you don't have the external drive connected or that terminator, that this thing will not work at all. So let's see in IMD if this thing even initializes or tries to read it. I know the motor's not spinning, but we should hear this relay click. And no, nothing happened at all. And I think that's because this drive requires that terminator to be connected. So I'm going to connect up the terminator here, and it just says disk terminator on it. And let's see if that makes this thing behave any differently. All right, let's see what happens now. Oh, hey, okay. It moved the head, it turned on the relay, or sorry, the solenoid there. Okay, I'm gonna turn on the AC motor, and I'm gonna stick the disc in here. Oh, first I should check the head. It looks pretty clean. Close this up. This thing is kind of noisy. It's the clamp here on the disc, so that's not anything else making that noise. All right, we'll take a look at that. It's reading the disc. It's having issues. All right, so let's alter the parameters here. So let's see, 24 sectors per track. Start sector, let's try MFM and 128. And let's write FEFE, or no, sorry, EFEF. All right, it's reading something, but it's having errors. Okay, I'm gonna hit F to format this track. And let's see what we see now. Come on. All right, well, it's having errors. So if I recall, it should have a 24 and a 24. And see how that number, it doesn't show 24 every time in the first column, and the second column has a number like 3, 4, 5, something like that. That is indicating that it's not working quite right. It is interesting, it does indicate that that format in the other drive did format this disk because it's reading something. Let me jump to like track 30. Okay, now it's reading nothing. So I'm gonna hit F to format this track, and let's see what happens. All right, so it's also having issues. There are 2 screws in here, so hopefully I can take this cover off and try to lubricate this clamp here, because it's sounding pretty nasty. Well, it sort of stopped making that horrible noise on its own. So I didn't really talk about this early on, but I can use IMD to actually make some floppy disks for the Model 2. Now, of course, because the interface is compatible with the Shugard interface, I should be able to use a GoTech with Flash Floppy as well. And I'd like to get this thing booting off an actual disk, if possible. And I was trying to analyze the disk to figure out what its format is, and it sees it at 6 sectors of 128 bytes, which clearly is not right. Let's see if I can keep analyzing this. It's not even really working either. It's not even really writing to the disk properly. All right, a little bit of time has passed, and watch this. Yes, we actually have this PC booting off an 8-inch disc. It's actually working. And this disc, it's full of files and stuff. I copy stuff onto it. I do not have the SD card, or yeah, the SD card booting. This is the XT IDE, it's right here, not inside the computer. So this is just running directly off this machine. Now, it's unfortunate that I didn't capture on camera the first time I got this working, and you can be sure that there was the "it freaking works" moment when I got this working. But unfortunately, due to time constraints, I had to work on this little by little, and I didn't have time to get the cameras all set up to do my testing. And yes, this is the drive from the TRS-80 Model II. So what did I do to make it work, you ask? Well, let's talk about it. Let me shut down this drive here. I'm gonna start by saying that the TRS-80 Model II drive had absolutely no faults at all with it. So really, with the problems I was having, there were two main issues. The first one was actually a software configuration issue on the PC. The first problem stems from the way I was formatting the disks. And if I'm in IMD here and I go to format the disk, if people remember, originally I was putting in 24 sectors and I was picking either FM or MFM for the encoding. FM being single density and MFM being double density. So for instance, how about I pick the 250 kilobits, and with this, the sector size is 256 bytes. When I formatted the floppy with those settings in either of the drives, when I tried to read it back, it would really struggle to read back anything. I was assuming there was a problem either with the cabling, the drive, the disk, one of those things. The problem was actually the way I configured the format of the disk. This was the Wikipedia article and the section within it where I determined how to set up the disk for formatting. 77 tracks, 24 tracks per sector, another 128 bytes for the MFM encoding or single density, or the 256 bytes for the double density. So that should give me a formatted capacity of 492K. The part that I was missing was that when you go to set up the format, it is not 250 kilobits FM or MFM, it is 500 kilobits per second FM or MFM. I think I was thrown for a loop on that particular setting because with 3.5 inch and 5.25 inch disk drives, which of course are what I'm used to, it's always using 250 kilobits per second when we're talking about double density disks. 500 kilobits per second is used for high density disks. So I didn't realize that the 8-inch disk drives actually use a 500 kilobits per second data rate. That is what they run at. And I actually don't remember where I saw it, but after reading different articles about it, I finally saw one that said the rate was 500, and like a light bulb went off my head, and I wait a second, all my testing was at 250. So I went back into IMD and I set it up for 500 just like this, same sector size. And when I formatted the disk and I went back to a line after that, it read it back perfectly. It just simply worked. So you might be asking now, how do I use an 8-inch disk on the PC and actually boot off of it? Well, it's actually a lot easier than you think. First, set up the BIOS for 1.44 megabyte drive because that enables 80 tracks and 500 kilobits per second because that's what a 1.44 meg drive can use. It can use 250 or 500 kilobits per second. And then I use the program nformat to create a custom format to allow me to format this disk as a DOS disk and have it just work with DOS. So I have two profiles set up here, the 500K one and the 654. So I have 77 tracks, so the same number of tracks as the original TRS-80 format. And then I have it set for 13 sectors per track. And the reason for that is originally I had it at 12 actually when I first did my testing with a DOS formatted disk. And it's because DOS uses 512 bytes per sector. And remember, the TRS-80 original format used 256. So it had 24 sectors per track, and this has half as much because, of course, we have sector sizes that are twice as big. So originally I had this at 12, and I actually increased it to 13 to try and get a little bit more space out of the disk. Number of heads is 1 because this is only a single-sided drive. Physical drive is 0, so that's the A drive. And the rest of the settings here were just filled in by nformat once you put in the sectors per track. And that's it. I was able to format the disk perfectly. I sysed it so that I copied DOS onto it, and then I copied some files onto it, and the machine boots right up off this 8-inch disk. And I was really happy to know that both of these disks formatted perfectly in IMD with no errors at all. So these disks are actually good. Oh, just because it's just so funny to look at, but look at the size comparison between the 8-inch disc and the 5.25 inch disc. It's so hilarious to see the difference. I absolutely, it just makes me giddy to look at these 8-inch discs. Now you notice here in nformat I have a disk that says 654K. I had another hunch that made me think that I could go higher with the number of sectors. These drives run at 360 RPM. That's how fast the spindle is on these 8-inch drives. Well, There's another drive on the PC that runs at that RPM, and it's the 1.22 megabyte high density drive. It runs at 360 RPM. It has two sides, so of course it has two heads, and it is a high density drive, so it runs at 500 kilobits per second. Well, 500 kilobits per second and 360 RPM is exactly what this drive is running at. So these disks, even though they're larger, are kind of the equivalent of single-sided high-density 5¼ inch disks. And of course, a PC's default format is 1.2 megabytes or 600K per side. And I figured that is even giving a gap space for older 286s and stuff. And usually you can squeeze out a little more capacity by shrinking that gap and putting more sectors on each track. And I figured there's no reason why this disk couldn't hold as much capacity as a 5¼ inch high density disk. Even though if you think about it, these are from the 70s, so that's pretty cool. But I don't know, since I've never used a TRS-80 Model II or any other machine with an 8-inch disk drive, I'm not sure that you could actually get this much space on a Model II, because I don't think it can handle those sectors that close together as this 386SX here can. So that was it. That was the entire reason why I couldn't get these disks to read properly. User error, I had it set to the wrong data rate. And incidentally, this 8-inch drive here, this is the one I already had, is actually in better shape than the one that was in the Model II. Both of them work perfectly, but this one is a bit quieter in its operation, and the other one has some rust on some of the screws, like on the spring right here and on the door, that this one doesn't have. So I may end up installing this one into the Model 1, although either would work. And just to retain that functionality with the loop back thing for the termination, I'll probably go ahead and run wires from the pull-up resistors on here over to those pins, just so if I ever get the external drive chassis, I can plug it in and it's actually going to work without having to open the computer and removing those jumpers. Now I actually have a third SA800 that I haven't tested yet, and this was in the box with the one I was just showing. Both of these came from a word processor or whatever. Theoretically, this one should not have termination jumpers on it. It doesn't. The terminators aren't there. And of course, that's because this would have been one of the middle drives in the chain. And I gotta say, this one is really clean inside. Okay, no, wait, it's dusty. It's just upside down. But it's funny how the PCB is yet a different color. The other one was like a dark green. The TRS-80 was sort of like a bluish color, and this one has this kind of light yellowish green color. I'm noticing here that the AC motor is a different brand. I think it's a different brand. The color is different, that's for sure. Anything else look different? No, this all looks pretty much exactly the same. Anyhow, since I have the whole rig out here, might as well test this drive out and see if the third one works, just so I know that it works, because up until this point, I've stored these away because I had no easy way to test them. Okay, here we are in IMD. Let's see if I can read the disk. It does not read. I'm gonna take the disk out and try the other one. Okay, try number 2, DIR A:. No, still not working. And look at that, IMD just cannot read this drive at all. Fascinating. Just in case this is not some kind of an alignment problem with this drive, I'm gonna try to format this disk with N format here. Nope, immediately it says unreadable, so that means that this drive is not working. Just to validate that is not something else that's wrong, I'm gonna swap to a different drive again. We'll try that. This drive is actually a bit quieter when the disk is in there and this is latched. I think the bearing on this one is a bit noisy. It kind of makes this whirring sound that I don't hear on here. All right, back in N format, I'm gonna try to format this disk. Here we go. There it goes, going very quickly. And if we go to IMD and I go to align, it'll have no problem reading this disk. It just formatted successfully. Okay, so at the top you see 1 through 13. That's all 13 sectors, 512 bytes each. And if I go to track 50, there we go, it's still reading 26. And we go to track 70, still reading 26. So yeah, totally working. So there's an amazing GitHub repo, Model 2 archive. They basically have all of the software for the Model 2. It's all here. And I've navigated over here to the Tandy folder, and I'm pretty sure I can find the operating system in here. You'll see there's tons of stuff. There you go, TRS-DOS like 2.0 here. And look at that, TS-DOS 2.0 IMD, single-sided floppy drive for the Model 2. So that's the exact file I want. I downloaded the repo so I can grab the zip file. So here's an image of it. 2.0A, I'll probably make this one actually for the Model 2. All right, here's TS-DOS 2.0. I'll just copy this onto the SD card for this thing. All right, in IMD, I'm gonna hit W for write. I have the disks in this Model 2 folder. There it is, TS-DOS. There was 3 files here. There's a blank disk. There's one where a bunch of files have been erased, so you have more free space. And then this is the original copy of the disks. So we're gonna pick that TRS-80 Model II, TRS-DOS, Disk Operating System 2.0A, and we're gonna hit enter. And here we go, it should write to this. 26 sectors of 128 bytes. Oh, the first track was actually FM, or single density, and now it's writing 256 bytes, which means that the rest of the disk is actually double density. The TRS-80 Model I did that as well. And that's because the original disk controller on the Model I was single density, or FM modulation, and later upgrades brought it up to double density. But the ROMs inside the TRS-80 Model I can only read the FM or single density track for booting, and then that track tells it to switch to MFM or double density. And that's clearly what's going on here with this thing as well. I wasn't aware that it did that. But this ability to write both single density and double density on a single disk image is one of the reasons why IMD is such a great program for this exact purpose. I am noticing that this Wikipedia article is wrong about the 24 sectors per track. It's actually 26. And that's evidenced by what we're seeing on the disk image itself here, 26 sectors of 256 bytes or 128 bytes. This is definitely a slow process, but at the end of this, I'm gonna have a boot disk that I can actually boot the Model 2 into an operating system. And that archive, which was like 5 gigabytes in size, has all the other software I could ever want for the Model 2. There we go. It successfully wrote the disk. And what I'm gonna do is just apply this label to the disk. There it is. Well, that was a little bit of a marathon. I know this video is super long. I'm gonna try to put index marks in it so people can jump to different sections, maybe about termination, about how to write the disks with IMD, things like that. But I am ecstatic. I think I was really dreading the whole disk drive part of the Model 2, and now this thing works. I know I have 2 good drives at least. Hopefully I'll be able to fix the 3rd one. That'll be a future video, so get subscribed for that. But I know now I have a boot disk, so when the Model 2 comes together, if it indeed works, I can actually boot something up. I'm really excited about that. I'm hoping on next week's video, I can get the Model 2 assembled to a point where I can power it up and see if the circuitry and electronics actually works. And if it does, then I can boot this to an OS. Now, I know I won't be able to type anything because that Keytronic keyboard is a disaster and I have to refoam that whole thing. And trying to work on this in my spare time means that it can be a little bit difficult. So there might be a little bit of a gap between this video and the next Model 1 video, but don't worry, it'll be coming up because I've made a lot of progress on the Model 1 when it comes to repairing the rust and cleaning, all that other stuff. So watch for that. I want to thank my patrons whose names are scrolling up the side of the screen right now. If you want to become a patron yourself, you can do so. There's a link in the description. Don't forget to check out my 2nd channel. I got mail call stuff and random stuff over there. Lately it's been a lot of mail call items, but yeah, they'll just be cool random videos. And don't forget to get subscribed and put your comments down below and I don't know, all the usual stuff. And yeah, big thanks to a local viewer here who donated this machine to me. It's been quite a bit of work so far, but kind of cool nonetheless, kind of fun and exciting as I make progress on it. All right, that is gonna be it. So stay healthy, stay safe, and I'll see you next time. Bye-bye.